Okay, Assalamualaikum and hi. Okay, so this is a video. The video will show you on how to do tutorial 1.2 from question 12 until question 17. Okay, so now let's look at question 12. So the density of 15% iron trinitrate contains 30 gram of ferrum trinitrate is 1.16 gram per ml at 25 degrees Celsius. So now first, you must take out the information given. So here is given the percentage by mass. Next, okay, given the mass of solute. Next, given the density. Okay, so now the question asks you to calculate the volume of a solution. So now we first must write down the formula of scribble down, write down the formula for percentage by mass. Okay, so percentage by mass equal to mass of solute over mass of solution in gram times by 100. Next, if we have density of solution, formula is mass of solution in gram over volume of solution in volume of solution in ml. Right, so now what are the other information that we have? We have mass of solute, which is equal to 30 gram. Okay, so the question asks you to calculate the volume of a solution. So volume of solution is in this density punya equation. So now that's mean before we found out the mass of solution, we must first find out the mass of solution. So how do we find out the mass of solution? Is from the percentage by mass. Okay, percentage by mass. So by substituting the mass of solute given, we can find out the mass of solution. Next, after finding out the mass of solution, you can substitute the mass of solution into this density equation, so you'll get the volume of solution. Okay, so you don't have to assume for this equation. Okay, so then in your answer paper, the first thing you should do is write the formula of percentage by mass of solute in gram over mass of solution in gram times 100. Then substitute the value of percentage by mass, which is 15. Mass of solute is 30 gram. Therefore, mass of solution times 100. So you'll get mass of solution equal to 200 gram. Right? Next, okay, we substitute the value of mass of solution that we get into this equation. First, write down the equation. So the density of solution given is 1.16 gram per ml. Mass of solution is 200 gram. Next, we'll get the volume of solution, which is in ml. Equal to 200 divided by 172.41 ml. So this is the answer for question 1. Next, we move on to question 2. Okay, the question 2 asks you to calculate the molarity. What is the formula of molarity? It is moles of solute over volume of solution. So now we already have the volume of solution from part part 1. So that means you just have to find out the mole of solute. So what is the mole of solute? Just divide the mass over molar mass. Okay, so for example, question number 2. First, we must find out the molar mass. Molar mass of our solute, which is ferrum trinitrate. Okay, so please make sure you write the word molar mass instead of RMM, right? Because RMM got no unit. So when you got no unit, okay, you cannot cancel the unit of gram. Therefore, okay, you must write down molar mass instead of RMM. Right? So what is the molar mass of ferrum 393? Is okay 241.9 gram per mole. So the first step is find out the mole of solute or mole of ferrum nitrate. Okay, equal to mass over molar mass. Mass is 30 gram over 241.9 gram per mole. So you will get 0.124 mole. Next, substitute into the molarity formula. Equal to moles of solute, which is our ferrum 393, over volume of solution in liter. Right, so moles of solute equal to 0.124 mole over volume of solution is 0.1724 liter. So you will get 0.72 molar. Simple. Right, please make sure your final answer must have the correct unit. Okay, capital M or mole per liter. Next, question number 3. Molality equal to what? Equal to moles of solute over mass of solvent. So now we only have the mass of solute, but we don't have the mass of solvent. Okay, so we must first find out the mass of solvent. So mass of solvent equal to mass of solution minus mass of solute. Mass of solution you already get in part 1. Okay, so 200 gram minus 30 gram equal to 170 gram. Okay, so now write the molarity formula. Molarity equal to moles of solute over mass of solvent. Moles of solute, mole, mass of solvent in kilo. So now moles of solute equal to 0.124 mole over 0.170 kilo, because you need to convert this into kilo. So we'll get 0.73 small m.